So moving on to the last question that is asked in test series 3 in the 2 mark section is question number 38, test series 3. So from the subject measurements. So here we have a wattmeter whose current coil is connected in series with the load, and the pressure coil is connected towards the load side as given in the problem. So if this is my input voltage, so this is the current coil which is of negligible resistance 0 ohm, and if this is the current that is flowing through the current coil, and if this is IPC pressure coil current, this is my pressure coil, this is the load. So here the specifications are: the load has 2 ohm resistance with an inductance of 0.25 Henry, and the pressure coil has a resistance of 1 kilo ohm and an inductance of 5.6 millihenry. So we need to calculate the power measured by power reading by the instrument is what? So power is nothing but VI applied by IC into cos of angle, resultant angle. This we will calculate watts. So IC is nothing but IPC plus I load current. This is my I load. So here we need to calculate IL, which is nothing but, so first we can calculate ZL as 2 ohms plus J times omega L, 2 pi into 50 hertz into the inductance is 0.25, so that we get it as 2 times J of 7.5 ohms. So IL is nothing but the applied voltage is 200 divided by 2 plus J times 78.5 ohms. So this, when we solve, we comes it as 0.0648 minus J times 2.55 amperes. So now we will calculate IPC. So IPC also in the similar way. So 200 divided by 1k plus J times 2 pi into 50 into, so the inductance is 5.6 milli. So this we get it as 200 divided, so this on solving we get it as 0.2 minus J times 0.000352 amperes. So this is my IPC. So IC is nothing but IL plus IPC, so which comes as 0.2648 minus J times 2.550332. So here the phase difference theta is nothing but tan inverse minus 0.000352 divided by 0.2, so this comes as minus 0.1 degrees. So here the resultant phase 5 is tan inverse minus 2.550332 divided by 0.2648, so this comes as minus 84.07 degrees. So the resultant phase, which is nothing but 5 minus theta between IC and IPC, is nothing but minus 83.97 degrees. So the cos of 5 minus theta is nothing but 0.105 radians. So we know the power dissipated is nothing but V into IC times cos of 5 minus theta. So if we substitute the values, 200 into the current has 2.56. If I take the magnitude of this IC, mod of IC is 2.56 amperes into 0.105. So on solving we get it as 53.76 watts. So the correct option, so the key is D. Thank you.